Hey guys, today I wanted to show you a few logarithm properties and how what might feel like a kind of a dead topic of log properties is actually quite important and quite useful to answer calculations even today. So, the entirety of this lesson is built on these fundamental log properties, which are ways that you can rewrite expressions that have logs in them in different ways. I like to think of a logarithm as a tool that decreases the complexity of a problem. And I actually use the metaphor that my 2-year-old daughter, she can't eat big pieces of food yet, and so we're constantly cutting up her meat into small little pieces and things like that, bite-sized pieces that she can do. That's effectively what a logarithm can do. So let's look at this first property, the product property of logarithms. Product property can take a product, so the logarithm of some sort of a multiplication problem, and it can rewrite it as smaller bite-sized logarithms that are added together. That can be a really useful thing. It can, like I said, make a complicated problem, a multiplication, it can turn it into an addition problem. Likewise, the quotient property, if you have the log of a fraction, you can rewrite that as two smaller logs that are being subtracted. Now you can also make a subtraction problem. You can turn it into a division problem if you want to do the opposite effect. But usually log properties are used to make a complex problem simpler. I'm going to jump down to the power property a second. If you have an exponent in an expression, for instance, we've got log of something to the p power, we can rewrite that as that exponent can get pulled out in front as a multiplier, just p times the log of something simple. And so that's, again, is a really useful tool that makes a complicated power problem into just a regular simple multiplication of a scale factor. And then there's another property which is useful to know. The chain rule, or the change of base, is actually the more popular version of this. The change of base property we've already used a couple times. This allows you to calculate something like log base 4 of 100 on your calculator. Normally you can't type that in because there isn't a log base 4 button, but the change of base property allows us to rewrite this problem, which we don't have a calculator button for, as a problem with any other base. Maybe, for instance, we write this as a base 10. In this case, A is 4 and C is 100. And we're going to choose base B to be 10 because the log base 10 button's on our calculator. We could rewrite this as log of 100, log base 10 of 100 over log base 10 of 4. And this allows us to calculate that works out to numbers somewhere between 3 and 4. Let me calculate it a moment. Log 100 over log of 4 is 3.32 something. But the primary lesson today is on those purple properties and how they can be useful. So here are two typical problems that are presented, and that is to take a pretty nasty expression and rewrite it, expand it, we say, cut it up into little bitty pieces. I use the metaphor for. I want to break this logarithm up into small pieces that have at worst log base 4 of x or log base 4 of y in them, and there'll probably be a relatively big chain of them added or subtracted together and so forth. And so to do that, maybe the first thing I notice is that this is the log of a quotient. And so I'm going to break this up into two smaller logs that are subtraction. So I'll write it as log base 4 of the top 64x to the 5th minus log base 4 of the bottom, y to the 12th. And that's already a little bit better. It's smaller pieces, but we can do even smaller than that. For instance, in this first expression, I've got a product, two things that are being multiplied together. And so we can break this up into log base 4 of 64 and add to that log base 4 of x to the 5th. And so now that bite isn't quite as big as it was. And the rest of this is still the same, minus log base 4 of y to the 12th. And then we can do a little bit more simplification. For instance, I see I've got a power inside of a logarithm. And over here I've got another power inside of a logarithm. Those exponents inside can be pulled out as scaling factors, multipliers, on the outside. And so we can write this expression as still log base 4 of 64 plus 5, let me read my own handwriting here, 5 log base 4 of just x now. And then I can do minus 12 log base 4 of y. By the way, those parentheses, you can use them or you can not use them. I was kind of inconsistent here. I didn't use them at the beginning. Let me add them. So there's one more little thing I can do, perhaps to simplify this or to expand this a bit more. And
Kennedy Matheny to the middle school office. Kennedy.
And that is that I can turn log base 4 of 64, that's just a number. I can evaluate that. 4 to the 3rd power is 64, and so that's just 3. And so, anyway, I have broken this down into as small of pieces as I can that are either being added or subtracted or scaled, multiplied by 12. But it isn't as complicated as taking the logarithm of a gigantic fraction. Now, you can also do the reverse of that. You can take an expression that is expanded of a bunch of different logarithms, and you can build back together one logarithm of that. And so let me show you the reverse operation here. Maybe we deal with the fact that the inside of this looks like two logs being added together. I can condense that into a single log of those arguments multiplied. And so this could be written as log base 7 of 32 times 8. And in fact, while I'm doing this, why don't I do that multiplication? 32 times 8 is the number 256. So log base 7 of 256. And I still have the 1/2 as a multiplier in front. I haven't dealt with that yet, and we can do that in a second. So that 1/2 as a multiplier, last time we had multipliers, they came from exponents. Let's take that 1/2 and put it back inside as an exponent. And so this would be log base 7 of 256 raised to the 1/2 power, which is the same thing as the square root of 256. Let me check if that works out nicely. Square root of 256, yeah, that's 16. And so that expression at the very beginning, which is kind of annoying to try to type into a calculator with all the log base 7s in there, is the same thing as this much easier expression to look at, log base 7 of 16, the square root of 256. So there's an example of using these properties to expand and to condense properties, and that's usually about as far as most textbooks, worksheets, teachers require you to be able to understand logarithms. Now I think there's a whole lot more that can be done with logarithms, and so in my next video I'm going to show you how you can use logarithms to answer some questions. In fact, historically they were used. That was the way that calculations were done when there weren't calculators to be able to do these things. People used logarithms and log tables all the time to make calculations. But we can still do things today. We can answer questions that your calculator can't handle because they're not big enough. The answers are too big for your calculator to display, but we can still figure them out by using logarithms. And so check back in with that next video or see the next one in the playlist, and we'll learn about that.